Okay, let's unpack this. We are diving into a massive, really foundational shift that's happening in the EV world. And it's all being driven by one single high-tech component from BYD, the new TZ200XYAT electric motor.
It really does sound like a dense technical name plucked from an engineering manual.
Hmm.
But the implications couldn't be more important for you if you're tracking the future of electric mobility. This isn't just about giving a few vehicles a little horsepower bump.
Not at all.
We are looking at a standardized architecture upgrade that dictates how future mainstream electric vehicles are built, how much they weigh, and crucially, how they charge.
Exactly. Our mission today is to distill the latest data from these recent Chinese regulatory filings, specifically from the Ministry of Industry and Information Technology, or MIT. We want to understand how this powerful 240 kilowatt motor is setting a whole new industry baseline.
And we're talking about the crucial mid-range segment here.
The sweet spot of the market, yeah, where cars are, what, around 14 to 21,000 US dollars. This is where all the volume is.
And what's fascinating here is the sheer scale and the strategy behind it. BYD is taking this high-performance 800-volt compatible motor, which peaks out at around 322 horsepower, and they're making it standard across their biggest sellers, the Dynasty and Ocean series.
So models like the new Seal '07, the Seal '06 GT.
The Kinemax, exactly. That level of power used to scream performance package, not entry-level standard.
So performance is being democratized, but let's get under the hood. What makes this specific motor, the TZ200XYAT, the key to this whole shift?
Well, the official designation is a permanent magnet synchronous motor. It has a nominal continuous output of 120 kilowatts, but it's that peak output of 240 kilowatts that tells the real story. More critically, it's purpose-built for RWD 800-volt architecture vehicles.
Which, for you listening, means a shift toward higher voltage. That allows for smaller wires, less heat, and, well, just more efficiency overall.
And if they're standardizing on RWD 800V, that means some models currently running on older 400-volt platforms or even front-wheel drive. They're getting a total overhaul, right?
They have to be.
Absolutely. It signals either a straight-up architecture upgrade or, for some models like the Yuan Plus, a complete shift in the primary drive axle to RWD just to accommodate this new standard unit.
Let's dig into the internal specs for a second, because this is where the efficiency gains are hiding. We're seeing things like direct cooling systems, 10-layer flat wire stator windings, and silicon carbide seat technology. Why are those details so critical? They sound a bit like jargon.
Oh, they matter profoundly. Take the flat wire windings, sometimes called hairpin windings. Instead of round copper wire, they use these rectangular copper strips. This drastically increases what's called the slot fill.
Meaning less air and more copper packed into motor casing.
Exactly. This density reduces resistance, which allows the motor to be smaller, lighter, and way more power dense. You get more power from less material. And the seat technology, that's all about managing voltage and heat incredibly efficiently. It's the key to making the 800-volt architecture actually work reliably at these high-power outputs.
And that connects directly to the first major surprise we found in the sources, the weight loss puzzle. If you're making the motor more powerful with high-cost materials like Seawick, you'd usually expect the vehicle to get heavier, or at least stay the same.
And here's where it gets really interesting. The motor upgrade is accompanied by just staggering weight reduction across the whole lineup. It's a massive clue that they haven't just swapped out one motor for another, they've built an entirely new platform.
Give us the hard numbers. What did the filings say?
Okay, look at the CL06 GT hatchback. It's upgrading its top RWD models from a 165 kilowatt motor to this new 240 kilowatt unit. Despite that huge power jump, the vehicle drops from 1,940 kilos down to 1,750.
So wait, that's a 190 kilo drop. That's a massive 419-pound loss.
419 pounds. That is the weight of, what, 2 or 3 average adults? You don't lose that much weight just by optimizing a few small components.
No way.
Precisely. The weight reduction strongly suggests a new, significantly more advanced battery chemistry or design is the most likely contributor here. This lines up perfectly with BYD's hints that groundbreaking technology is coming for 2026.
So they're making the cars more powerful and much lighter at the same time.
All likely thanks to packaging efficiencies and battery innovation that are enabled by this new 800-volt secrecy architecture.
So the standardized motor is the flag we're seeing, but the real structural shift is the platform and the battery tech underneath it. Let's talk scale then. This isn't just a prototype. This is transforming entire vehicle lines, replacing multiple older motors with this one single high output standard.
And that standardization is the foundation of cost compression. When you can use the exact same motor, cooling system, and power electronics across 5 or 6 different models, your cost of goods just plummets. And that lets you deliver 320 horsepower as a baseline expectation in a $20,000 car.
The Kim-Max EV is a perfect example of this efficiency paradox. It's actually growing in size nearly 6 inches longer, and yet it's shedding weight while adding all this power.
It's engineering mastery.
Yeah.
The Kid-Max is jumping from an old 160 kilowatt motor on a 400-volt platform to this new 240 kilowatt unit on the 800-volt system. Despite growing, which usually adds mass, the filings show it manages a slight weight decrease overall. It's a testament to the lightweighting in the battery and platform.
And further up the chain, the new Seal 07 EV, it's moving closer to the flagship Han in size. It uses this exact same 240 kilowatt motor, and at 1,940 kilos, it is significantly lighter than the current version. The baseline for mainstream performance is just being dramatically redefined.
The 240 kilowatt RWD motor establishes a robust new floor, but then the question becomes, how do you differentiate the high-performance models?
Right.
That's where they leverage this standardization to stack power for the all-wheel drive variants.
Tell us how that scaling works.
We see the perfect roadmap in the Fangcheng Bao T3. It's a compact SUV. That model combines the standard 240 kilowatt RWD unit with a more powerful 135 kilowatt front motor. Together, they achieve a total system output of 375 kilowatts, a massive 503 horsepower.
So the 240 kilowatt unit becomes the efficient, high-volume rear engine, and they just slot in a high-output front motor for the AWD models. They're using the uniformity of the platform to control cost and complexity.
Exactly. This 240 kilowatt standard becomes the new boundary for mass market performance, sitting just below the truly premium stuff like the 580 kilowatt motor in, say, a Han L. It elevates the average buyer's experience without cutting into that top-tier market space.
Okay, now we get to the most fascinating part of this deep dive for me, the charging implications. For years, the promise of 800-volt architecture has been kind of hampered by charging on existing 400-volt infrastructure. A lot of automakers had to split their battery packs, and it just led to slow charging.
Yeah, that's because the battery's actual voltage often droops below its nominal rating.
Oh.
So when you plug into a 400-volt charger, the charger hits its amperage limit, its current capacity, long before it can reach the battery's true maximum power output. You end up charging way slower than the car is theoretically capable of.
This raises a critical question then. How does BYD, standardizing on an 800-volt platform, overcome this fundamental limitation with the new motor?
This is the real innovation, and it connects directly back to that SysTech technology we mentioned. BYD's strategy is, well, it's truly ingenious. The power electronics, the SysTech hardware that drives the motor, are also used as an onboard charger, and the motor windings themselves are used as a filter inductor.
Wait, hold on. So the components that make the car go forward are doing double duty as the charging manager. That sounds like a radical form of integration.
It is. Think of the motor as a massive muscle that not only moves the car, but is also capable of carefully regulating the flow of energy into the battery. This system takes the maximum DC output from the charging pile and regulates the voltage onboard the vehicle, ensuring the battery gets power efficiently, no matter what the charger is rated for.
And the practical benefit of that.
You eliminate the complexity, the weight, and the separate cost of a dedicated onboard charger, and you maximize efficiency. They claim the rated efficiency for their Cycle C electronics in this process is an astounding 99.86%.
That's a huge integration breakthrough. But let's circle back to that 240 kilowatt power rating of the motor. Why is that number so important for charging speed?
Because 240 kilowatts is a typical, highly prevalent power rating for the older, standard 400-volt DC fast chargers all across China. So because these new vehicles use the motor's integrated system to regulate charging, they can theoretically utilize the maximum rated output, the full 240 kilowatts, from a single charge gun of those existing chargers.
Ah, so they've optimized the vehicle to perfectly harvest the maximum energy from the most common charger available. It eliminates the inefficiencies that plague other 800-volt cars on 400-volt infrastructure.
Exactly. And for the future-proof, higher voltage, high-power chargers, the ones above 240 kilowatt, the current speculation is that these vehicles could charge at about 6C.
Okay, we need to define 6C for everyone listening because that sounds like Formula One speed.
6C just means charging at 6 times the battery's capacity rating.
Mm-hmm.
So while we don't know the exact battery size for all these new models yet,
Mm-hmm.
6C charging would translate to an astonishing 20% to 80% recharge time in roughly 8 minutes.
8 minutes. That completely changes the conversation around range anxiety and recharging convenience for the mass market.
It does.
Let's look at the final implications then. setting the market standard and what this means for future competition, the immediate effect of this has to be cost.
It's massive cost compression, achieved through platform uniformity. By using the same high-output motor to replace a whole range of older, less powerful units, they are driving down manufacturing costs. This means 240 kilowatt performance is no longer a luxury feature. It has instantly become the baseline expectation.
Forcing every competitor in that mid-range segment to meet or exceed it.
Exactly. And we know the Chinese market is famous for its rapid, intense competition.
It is ruthless. The chairman of BYD, Wang Chuanfu, noted that when a company raises the bar this high, competitors can be expected to reach that same level in about 18 months. This pace is what drives generational innovation so fast. We saw it when they doubled PHEV battery range practically overnight and forced the whole industry to scramble.
Yeah, and our sources make a pretty clear distinction between this rapid-fire environment and other global markets.
They do?
The sources highlight that because of this intense domestic competition, the pace of innovation in China is setting a new global benchmark. Markets where competition is less fierce, like the EU, they may struggle to match this pace. And for markets focused on protecting local industry, the analysis suggests they risk falling multiple technological generations behind what is quickly becoming the new global standard.
It's a powerful illustration of how fierce domestic competition accelerates technology for everyone. So, what does this all mean when we wrap it up for the person actually driving one of these new cars?
Well, the rollout of this TZ200XYAT motor signals two huge interconnected shifts for the mass market. First, a major boost in power and a critical reduction in vehicle weight. That's thanks to the underlying 800-volt architecture and advanced battery tech. And second, a major innovation in charging, using the motor components themselves to maximize speeds on existing 400-volt infrastructure while preparing for the hyper-fast 800-volt plus speeds of the future.
They've solved the performance gap and the charging convenience problem for the mid-market segment all at once just by intelligently integrating components. That is the definition of a generational leap.
It really provides a clear, high-value template for what every effective next-generation EV should look like.
So if 240 kilowatt performance and the ability to maximize 400-volt charging becomes the standard expectation for mass market EVs in China, what will happen in markets like the US or Europe that still rely so heavily on inconsistent or older 400-volt charging networks? Will the simple arrival of this technology force a global charging infrastructure upgrade faster than any regulation ever could? Something for you to mull over as you see new EVs hitting the roads. Thank you for joining us for this deep dive into the latest EV technology filings. We always appreciate you sharing your time with us and concentrating on the sources we bring to the table. If you found these insights valuable, please take a moment to follow the channel to ensure you don't miss our next deep dive.